Okay, where is it? Okay, so if I just rest my body and the entire pen over here, so my finger is my pivot, and this is my basically my scale, or you can say the plank. It has some components, some moments, which will cause it to move clockwise or anti-clockwise, right? So this moment is called turning effect of force. I hope it makes sense, right? So let me just introduce in this slide क्या होता क्या है, and then we will dive deeper into the moments and the principle of equilibrium क्या होता है in the next class, right? So turning effect of force is called the moment of the force, right? As Vardha said, it is called the moment of the force, right? So it depends upon both the size of the force and the distance from the pivot, right? What is pivot, by the way? Imagine this particular scenario. Let me just draw a good scale. Okay, imagine this is your scale, which is balanced out over here, right? This is your scale, and this is the pivot, right? So pivot is the point at which your scale is balanced, right? So you can see, okay, let's say we have a mass m1 over here, and we have mass m2 over here, right? This is the center of the pivot, right? And it is at a certain distance also, right? You can see it is at distance, let's say d1, and this is at a distance of d2. Okay, so this particular mass m1 will try to cause the scale to move in this direction, and this mass 2 will basically cause the motion in this anti-clockwise in clockwise direction, right? So these are called moments. Yes, Oba.
Sir, can I leave the meeting? I have another class. So should I
Okay,
leave?
sure. I'm just ending in 5 minutes. Okay, yeah, you can go. Watch the
Okay.
remaining.
Allah Hafiz.
Allah Hafiz.
Okay.
Okay, does this make sense? Okay,
Yes.
so now it depends upon two things, right? That is how far away it is from the pivot and what is the weight of the blocks. That means how much force are they applying, right? That is what is the weight one. Let me just draw using highlighters. What is the weight one over here, right? What is the weight two? So it depends upon the forces also, right? This is the weight one, which is also a force. This is the weight two. So it depends upon the force magnitude and how far away they are from the pivot, right? So if I want to define this, the formula for a moment of a force. So let's take example, like you have your doors. Obviously, you have doors in your apartments, right? You have a doorknob, right? You can just easily close and open your door, right? Try to open the door from the center, right? Imagine you have a door over here, and this is your doorknob, right? And at this particular point, they are fixed, right? They're fixed from here. Then you can open the door either like this, or you can close the door in this direction, right? I'm just saying, okay, after the class, try to open the gate from here, from this side. You would have difficulties opening it. You would have to apply more force. Think about that in the next class. I will ask the question, right? So what is moment? So moment is basically force into perpendicular distance from the pivot, F into T, right? So this is the formula of moment. That is, want to basically multiply. You want to basically multiply the force that is applied times the distance from the pivot over here, right? Imagine this scenario, the simple scenario, which I want to explain. Imagine this, right? Let's say this is your block over, this is your scale over here. It is fixed from here, right? This is the pivot over here, right? This is the pivot over here, and you're applying a force in this direction, right? F, and this is the distance from the pivot, right? D. So you always want to take a distance that is at a perpendicular distance, right? So you should always have a 90 degree between the force and distance, right? So the moment of this particular scenario is going to be force into distance, right? That is moment, right? That is how it is basically causing a movement around the pivot over here, right? It is going to be a turning effect, right? It's going to cause a turning mechanism. Okay. And let's talk about the SI unit. Can anyone tell me what is the SI unit of moment from the formula? Just see the formula and tell me the SI unit. Okay, Newton meter, right? So you know, okay, force is measured in newtons and distance is length, that is measured in meters. So therefore, the SI unit of moment is Newton meter, right? That is written over here. Okay, that is Newton meter. So if you want to define this moment, if you have a question in your exam of 1 mark in your theory, just write a definition. Okay, moment of a force is force time is the product of force and perpendicular distance from the pivot. That's it. You get 1 mark. Okay. So any questions till now? If everything is clear till now, give me a thumbs up. It is clear to Ryan, Vardha. What about other kids? Hamza, Mashal, and Maeve. Is it clear till now? It's clear to Hamza. What about Mashal? Is Mashal here? Is she chilling out?
No, sir. The last one means the turning effect of forces and the moment was not clear.
Yeah.
The rest of them are clear.
Is it why? How is it not clear? If your question asked.
I didn't quite understand the whole point of the topic.
Yeah.
So,
Just go and just play with your door. जो आपको बताया ना मैंने. This is homework. Let's see. Just
okay,
try to open your gate from the center instead of the doorknob. Okay.
okay.
Okay. Okay. Yes. On an object which is let's say fixed from one point, right? So if I apply a force in this direction, so what does it do? It causes the object to turn, right? It causes the object to turn, okay, either clockwise or anti-clockwise, right? So this phenomenon is called moment, okay? And how do I find moment? Moment is basically force into perpendicular distance from the pivot, right? So you always want to take a distance that is at 90 degrees with the force, okay? That is very important. Then you derive the SI unit of moment. You know the force is measured in newtons, distance is measured in meters. So what do we get as the moment SI unit? That is Newton meter, right? Does that make sense to you guys? I believe it does because I build up on this. Okay. If it is clear till now on the movement section, give me a thumbs up. Now I'm going to move on to the next part. It's clear to Mashal, Varda, Ayan. Is Ruba here? Is or Ruba chilling out?
Sir, I'm here.
Okay,
It's
okay,
clear.
okay, you're here. Okay, now let's do some example, right? So you did the experiment, right? You did the experiment with your door. And Hamza and Mashal said, okay, sir, if I apply the force, if I try to open the door from the center, Ryan also said that, I will have to apply more force, sir. Okay. So let's talk about it, right? Let's see scenario A, let's see scenario B, right? Let's find the moment for scenario A. Okay, so let me just insert a blank slide and let me duplicate this. So let's take a screenshot. Okay, now imagine this is your door and it is basically fixed from here, which you can see this is a fulcrum, right? Pivot. Okay. So now let's say you're opening, this is the door number over here, the D, and you're opening the gate from here, right? And the distance from the pivot, which is perpendicular to the force, is 3 meters. So your D is this. This is your force. Let's apply the formula. So what is the formula of moment? How do we find moment? Moment equals to
M
what?
multiplied by D.
Yeah, it's basically force into perpendicular distance from the pivot, right? So if I just put in the values, I get what? Let's say you were opening your gate from your doorknob and you're applying a force of 5 newtons and your doorknob had a distance of 3 meters from the pivot, right? So your moment is coming out to be that is 15 Newton meter, right? This means that you need this much moment to open your door, right? At least 15 Newton meter to open your door, right? If you're applying a force of 5 newtons, right? Okay. So now let's imagine if I'm trying to open the door from the center, right? Let me insert a blank slide. So now let's imagine the experiment which I told you guys to do is that okay, now try to open the gate from your center, open your door from the center of your door, right? Let's say now you're applying a force here, and the distance which is perpendicular to the force is this, right? This is your DNA, right? So again, the formula apply करें, you will get the following thing that moment equals to F into D. So now just put in the values. Your force is 5 and your distance from the pivot is 1.5. So gonna get what? Gonna get 7.5 Newton meter. That means it is this moment is not enough to open the door, right? You require at least 15 Newton meter at a force of 5. So now if I say to you guys the following thing, let's say Now let's forget the force is given to you, right? Let's forget this. You don't have the force given, right? That is unknown. If I say, okay, now find the force, find the force needed to open the gate, open the door successfully. Okay. And given that it takes a moment of 15 Newton meter open, right? So we want to find F, that is of 3 months. So guys, take out your calculators, take out your copies, pencil, and I'm going to give you 3 minutes to solve this question and get an answer. This would give you the reason okay, why you need to plan more food, right? Okay, so let's start. I guess everyone is done. Yes, you can raise down your hands. Done. Okay, so let's solve it out. Let's solve it out. It's pretty simple, right? Just to give you a proof, okay, why was it true, right? So let's solve it out. You know, okay, what is given to you. Write down the data, what is given, always, right? You're given, okay, the moment is 15 Newton meter, right? So now find the D. What is the D over here? The distance from the pivot.
1.5.
You always need to take the reference from the force to the pivot, right? That is this. That is the distance, right? So your distance is also given, that is 1.5, sorry, meters. So now you want to find what? You want to find F force. So just write down the formula. You have 1 mark for the formula, right? So movement is equals to Ft. Get 1 mark for this. And just now put in the values. 15 equals to F into 1.5. And F equals to basically 15 upon 1.5. Therefore, that gives you answer of F equals to 10 newtons. Okay. So just raise your hand if your answer is matching. So this basically gives you 1 mark, and this answer gives you 1 mark. Right? So you get 3 marks. Yeah, okay, so that's good. Everyone's answer matches. Okay. So I guess now it makes sense. Okay. Now if you try to open the door from the center, so now you will have to apply more force, right? Initially it was 5 newtons. Now you have to apply double force. Okay.